Right, capacitors. Capacitors store charge. So if we've got this capacitor and we connect it up to a battery, what will happen is the current, well, the electrons are going to be going this way around, aren't they? Because the electrons are going to be repelled from the negative bit of the battery. So these are going to go around here and they are going to build up on that plate there. So that will be a negative plate of the capacitor. That's going to repel electrons from this plate. So the same number of electrons is sitting on that side will get repelled from that side. These will come round to the positive side of the battery. So that will leave that side of the capacitor to be positive. Okay, so that's what a capacitor does. So the first sort of question you could be asked is, what direction will the current flow in? Well, you've got the electrons going this way round, so that means that we're going to have a current coming this way round. Remember, it's the opposite direction. But what's going to happen to the current is we'd have whatever the initial current is would drop down to zero, because when there's a lot of electrons sitting on that negative plate, they're going to stop any more electrons joining in, because those electrons are going to get repelled away by the electrons that are already there. So if we've got a charging graph for capacitors, it's this shape. Now, you do get given a couple of equations for capacitors. You get given one in the form of x equals x0 e to the minus t over CR. Now, when we're charging a capacitor, for current, we could use this. I is equal to I0 e to the minus t over CR, where I0 is your initial current and I is whatever the current is at a particular time after you've started charging it. Okay, so the current will obviously decrease to, well, tend towards zero as it is fully charged. Now, the next bit that you need to be able to do is think about if we discharge that capacitor. So if we've charged it up, we could have a separate circuit at the top here where we discharge it through a resistor. And usually the way they sort of look at doing that is you have a switch that can be connected that way to charge it and then flipped round to that way to discharge it. First thing to note is these electrons will be going this way around the circuit. So if we had an ammeter here, when we were charging it, it would pick up the electrons going through one way, maybe a positive current. When we're discharging it, the electrons will be going the other way, so a negative current. And then this current's going to discharge, and it's going to discharge in a similar way. So the electrons are going to be repelled strongest first of all, so you're going to have most going first of all, and it getting less and less. So we're going to have the same decay curve for current, whether it's charging or discharging. Now, the rate at which it discharges does depend on the resistance of that resistor. And that's one of the ways that we can look at finding the capacitance of a capacitor, because we've got this equation here. Now, you're also given the equation T equals CR. This happens when T is equal to the time constant. So the time constant is the time at which T is equal to C times R. Now, R is the resistance of the circuit. C is the capacitance of the capacitor. Now, when you've got T is equal to CR, this equation here becomes I is equal to I0 e to the minus 1. Now, e to the minus 1, you can put it into your calculator. It's about 0.37. So I is equal to 0.37 I0 says that when I gets down to 0.37 of I0, that must be when T is equal to CR. So the first way that you can find out the capacitance is from your graph here, you do 0.37 times I0, read across and down and see what time that took. Whatever that time is, you can put that equal to CR and you can find what the capacitance is. The other way they might get you to do it, I doubt whether they would, but they might, is to take natural logs of the equation. Because if you took natural logs of this equation here, you'd get the natural log of I is equal to the natural log of I0 minus t over CR. Then, if you plotted a graph of log I against t, you'd get an intercept of log I0 and you'd get a gradient of minus 1 over CR. So if you discharged a capacitor, took a reading of the current every 10 seconds, something like that, plotted that graph, you could find the capacitance by using minus 1 over CR. So they're the first couple of things that you need to be aware of, looking at how you can find the capacitance of a capacitor. Now, there's a couple of other things that you need to be able to do, but I'll put that onto the next video.